Hello everyone. This is Dr. Deeksha Yajurvedi. I'm Associate Professor in Department of Chemistry at Raghunath Girls Postgraduate College, Meerut. The topic for today's discussion is gels. As we all have studied about various type of colloids depending upon the dispersed phase and dispersion medium. So gel is one of the type of the colloids. It is a colloidal system in which a liquid is dispersed in a solid. That is, the colloidal system in which the dispersed phase is liquid and the dispersion medium is solid. So gel is a semi-solid that can have properties ranging from soft and weak to hard and tough. They are defined as substantially dilute cross-linked systems which exhibits no flow when in the steady state, although the liquid phase may still diffuse through this system. A gel has been defined phenomenologically as a soft, solid, or solid-like material consisting of two or more components, one of which is a liquid which is present in substantial quantity. Gels are mostly liquid by mass, yet they behave like solids because of a three-dimensional cross-linked network within the liquid. The word gel was coined by 19th century Scottish chemist Thomas Graham by clipping it from the word gelatin. Some of the examples which we encounter in our daily lives of gels are gum arabic, then gelatin, processed cheese, silicic acid, ferric hydroxide, salt. These all are examples of gels. When a warm sol of gelatin is cooled down, it sets to a semi-solid mass, which is a gel. So all gems, jellies, curd, butter, shoe polishes, they fall in the category of gels. Now the lyophilic salts may be coagulated to give a semi-solid jelly-like mass which encloses all the liquid present in the sol. So when a colloidal solution is coagulated, a precipitate is formed which may be or may not be gelatinous. Under certain conditions, it may be possible to obtain the dispersed phase, that is liquid, as more or less rigid mass enclosing within it all of the liquid. The process of formation of gel is known as gelation, and the resulting colloidal system formed is known as gel. The nature of gel depends on the coexistence between the solid network and the liquid medium. A gel is a soft material which can be easily cut with a knife. If somehow we remove the liquid phase from the gel, it becomes aerogel or xerogel, which depends upon the drying conditions of the gel. Depending upon the liquid enclosed in the gel, gel may be called as hydrogel if the liquid enclosed is water. It can be known as alkogel if the liquid enclosed is alcohol, or ammonogel if the liquid enclosed is ammonia. So in this figure, we can easily see the cross-linking within the fluid that gives a gel-like structure and contributes to the adhesiveness. So in this way, gels are a dispersion of molecules of liquid within a solid medium. We can see the three-dimensional cross-linking structure of the solid particles in between which the liquid is entrapped. Now let us focus on few of the characteristics of gel. As I have told you earlier, colloidal system in which the dispersed phase is liquid and dispersion medium is solid, that is known as gel. So it is an immobile semi-solid having honeycomb-like structure. Many gels have a tendency to absorb liquid and they swell. No such agent is required for the gel formation. Gels may be classified on the basis of elastic properties into two categories, that is elastic gel and non-elastic gel. And unlike other colloidal systems, they do not show the Tyndall effect. That means they don't scatter the light. They do not show the rapid Brownian movement, zigzag motion, which is exhibited by colloidal particles. And they also do not show electrophoresis. Electrophoresis is the property of the particles to move towards the oppositely charged electrode under the influence of applied electrode potential. So these properties are not shown by the gels. If we classify gel, they can be classified into two types on the basis of their elastic properties. They can be either elastic gel or non-elastic gels. Elastic gels are also known as reversible gels. So what happens that these are the gels which possess the property of elasticity. They readily change their shape on applying the force and return to original shape when the applied force is removed. So when we heat up the gel carefully, it forms a dry mass. And if this dried mass is again placed in contact with the liquid, it absorbs liquid, swell up and regain their original form. They change to solid mass on dehydration, which can be converted into gel back by addition of water, followed by heating and cooling. So that's why they are known as reversible gels. Now, when these gels are placed in contact with water, they absorb water and swell up. This is a very unique property of gel which is known as imbibition. Some of the characteristics of elastic gels are, as I told you, they are reversible. Means they can be dried up, they become dry, and when they are kept in contact with water, they can again take up the solvent. They are lyophilic in nature. They show the property of imbibition, and the original gel can be obtained again by addition of water or liquid to elastic solid. Gels which are made up of organic substance are elastic gels. Now coming to the second category, that is non-elastic gels, which are also known as irreversible gels. These are the gels which on heating loses liquid and gets converted into dry mass. But they cannot absorb liquid and regain their original form when they are placed in contact with the liquid. So this is the basic difference between elastic gels and non-elastic gels. Elastic gels are capable of absorbing liquid and regaining their original form when placed in contact with the liquid, but non-elastic gels cannot absorb liquid and regain their original form when they're placed in contact with the liquid. That's why the name irreversible gels. They do not show the phenomena of imbibition. Some of the examples of non-elastic gels are like silica gel, solid alcohol, hydroxides of iron, aluminium, and chromium. They all fall in the category of non-elastic gels. Few characteristics of non-elastic gels are that they do not have the property of elasticity. So these are the gels which are rigid. They change into solid mass on dehydration, which becomes rigid and cannot be converted back into original form by heating with water on heating. They give, in fact, a powdered form. So the original gel cannot be recovered by addition of water or liquid to the powder. That's why they are irreversible in nature. They are actually lyophobic and do not show the property of imbibition. Gels made up of inorganic substances are non-elastic gels. Now coming to a very important property of gels, that is swelling or imbibition. The tendency of a gel to take up a large quantity of water or liquid and goes on increase in volume. This phenomena is known as swelling of gel or the smiling of gel, or we also call it as imbibition of gel. Imbibition is shown only by elastic gels. Now, next very important property is synerisis. In imbibition, the volume is increased, but if somehow due to loss of liquid on standing, there's a decrease in the volume of gel, then this phenomenon is known as synerisis or weeping of gel. Many inorganic gels on standing undergo shrinkage, which is accompanied by exudation of liquid. This process is actually reverse of imbibition. You can see from the figure that the process of water sorption, that is, the gel swells up when it is placed in water, so the volume increases. Here the volume is increased, but in synerisis, the fluids is wept out or exudation occurs. So there is shrinking of the gel and reduction in the volume. Next important property of gels is thixotropy. Thixo means touch, tropy means movement. So some gels are capable of turning into a sol on shaking, and again they reset to the gel on standing. So when you touch them, gel converts into sol, but if you leave it or uh, just leave it, then it becomes back the gel. This reversible sol gel transformation is known as thixotropy. Iron oxide and silver oxide gels exhibit this property. And now in the market, thixotropic paints are also available. So when you just shake the paints, they become in the sol form. But on standing, they become gel again. So this is as shown in the figure, this is a reversible sol gel transformation. The next property is the fragile nature. If we take out a newly opened container of yogurt or sour cream, gel appears to be smooth and firm. But once you have spooned out the material, little puddles of liquid appear in the hollowed portion. As the spoon is plunged into the gel, it pulls the nearby layers of the gel along with it, so as a result, it creates a shearing action that breaks it apart and results in releasing of the liquid which is trapped inside. Now, on the basis of Hofmeister was a scientist who arranged all the cations and anions on the basis of the property, that means the effect of salt on the swelling or imbibition of gel, because different ions are found to have different effect on swelling. For example, in presence of iodide ions, the process of imbibition is very fast, so much fast that even at room temperature, imbibition takes place, while for the other ions, heating is required. So Hofmeister arranged cations and anions in their series, which is known as lyotropic series or Hofmeister series. The ions which are ordered from top to the bottom, means which are kept at the top, they are most effective in precipitating the proteins out of the solution, while the ions which are kept at the bottom, they are the least effective in precipitating the proteins out of the solution. So this was a very short topic about the gels, and before I sum up, let us discuss few of the applications. Alcohol, which is jellied with calcium acetate, it is used as a solid fuel for military field services. We have been using silica gel. It is the most valuable adsorbing and desiccating or drying agent which is used in the laboratory or in industry also. Now, many articles of a common use are gels like curd, fruit creams, fruit jams, butter, cheese, jellies, the various foodstuffs. So they all are example of gels. So in this video, I have tried to give you a brief outline about the gels, their definition, classification, and their application. Thank you so much.